Hi class, today I want to discuss about triple integrals. At the end of this class, I hope that students should be able to sketch the solid, which is surface, or we call 3D of integration. And then student can evaluate the triple integral for Cartesian, cylindrical, and spherical coordinates. And last, student can evaluate the application of triple integral. So we have volume, mass, center of mass, and moment. And remember, we also have centroid. So the outline of this topic is we have triple integrals. So under the triple integrals, we have Cartesian coordinates, cylindrical coordinates, and spherical coordinates. And the last one, we will talk about application of triple integrals. So what is triple integral? So the definition of triple integral is similar with the double integral, which is we have a limit n approaches to infinity, then we want to get the limit of f for x, y, z. Similar with the double integral, we have iterated integrals. So we have to know which one we want to integrate first, second, and third integration. Before we proceed further, please take attention for the sentence. We have bounded below the, bounded below by, bounded above the, bounded above by. So actually class, if you want to sketch the region and you want to sketch the surface, so bounded below by is similar with bounded above the. Bounded above by is similar with bounded below the. So make sure you try to understand this term. So the first one, we have Cartesian coordinates. Remember, we have two types. First type is rectangular solid. Okay, if the solid is rectangle, so the limit of integration is a to b for x, c to d for y, k to l for z. Okay, so all the limit are constant. So for Cartesian, you can choose the type of order for integration. 6 types, okay? You can choose whether dx dy dz, dx dz dy, dy dx dz, dy dz dx, dz dy dx, or dz dx dy. So it's depend on us which one we want to use. Okay, we look at example 1. Limits are directly given. Okay, the question has to evaluate z square y e power of x dv over the rectangular box defined by 0 to 1 for x, 1 to 2 for y, negative 1 to 1 for z. You see, for triple integral, we use dv. Now, we know that the limit of integration for x is from 0 to 1. And then y from 1 to 2, z from negative 1 to 1. Okay, first of all, how to solve? We have to choose our dv. Okay, let's say we want to choose dx, dy, dz. So, what is our z? Okay, dz. The limit for z is from, we look at the question, from negative 1 to 1. Okay? And then we look at dy. Dy from what? Okay, we look at the question. Dy from 1 to 2. Okay, next, dx. Dx is from 0 to 1. Let us look at the question. X is from 0 to 1. So what we can do? We have to integrate. First, we integrate with respect to x first. Okay, we integrate with respect to x first. Then what we get? Integrate ex. So we will get ex. And then y and z just remain constant. Okay, next, what we should do is we substitute 0 and 1. So we will get e minus 1. So next class, we have to integrate with respect to dy. So we check, we have y here. So what we get? Y squared over 2. And then we substitute the value of 1 to 2. Alright? Then we will get 3 over 2 e minus 1. And then lastly, we have to integrate with respect to z. So integrate z square. Okay, so we integrate, what we get? 3 over 2 e minus 1 integrate z cubed over 3 from -1 to 1. Then if we substitute, we will get 3 over 2 e minus 1 1 over 3 minus, so we will get plus 1 over 3. So last we will get 3 over 2 e minus 1 and then multiply with 2 over 3. So cancel this, we will get e minus 1. So the answer is e minus 1.